So let's do one more. This time we have to add a little bit of an element of fun to it here. So we've got an equation, f of x, and we want to find the equation of the line tangent to this graph of f of x at the given point, in this case 2, 2. By the way, you should be able to verify that the point 2, 2 is on the graph, because if you substitute in 2 for x, you're going to have 2 squared plus 5, which is 9, times 2 times 1/3. Well, the square root of 9 is 3, divided by 3 is 1, times 2. Yeah, y equals 2 for sure. Okay, so we've got this function that passes somewhere through the point 2, 2, and we want to find the tangent of the line, equation of the line tangent to the graph at that given point. So that means we're going to have to find a derivative here. All right, well, that's in case you missed the last one, this is a combination where we're doing a product rule and a chain rule at the same time. So let's go through those steps once again. We're going to take our derivative by treating this as a product of two functions. So we've got a function f, and we've got a function g, and we know that if we take the derivative with respect to x of f times g, our thinking goes take f prime times g plus g prime times f. And so we're going to work it that way, although actually I think last time I put it f times g prime in this second, so I'll be consistent. F times g prime. Okay. So if g is our function's square root of x squared plus 5, we know we're going to be taking a chain rule type of approach to that one, and if f is equal to 1/3 x, well, that's just a straight rule that we can deal with by direct differentiation. So, all right, y prime, f prime of x, that's our function of our original function f right here. That's going to be the derivative of f. So the derivative of 1/3 x is just 1/3 times the function g. And I'll write it in this exponential form for convenience. X squared plus 5 raised to the 1/2, right? Notice we're not doing anything to g here. We're just taking the original g and multiplying it by the derivative of f. Plus, and we're going to have f, which is 1/3 x. But this time that's going to be multiplied by the derivative of g. So now we need to use our chain rule. So what is g prime of x? Well, in this case, g prime of x is going to be 1/2 times the inner function x squared plus 5 to the 1/2 minus 1, so that's negative 1/2 power, times the derivative of the inner function. In this case, that's 2x. All right, now I'm going to go through some steps to simplify this, but I'll tell you what's going to happen. We're going to end up with x over x squared plus 5 to the 1/2 power. All right. Well, now at this point, yes, if we were interested in rewriting this function, we actually have a bit to go that we could, a number of things that we could do to simplify this out and rewrite a new algebraic expression for our derivative. But in point in fact, the original function right here isn't too bad to deal with. And what we really want to do is we want to find the slope of the line tangent to the curve at x equals 2. So I'm not even going to bother with some of the formalities right here. I'm just going to go ahead and find f prime of 2, and let's see what happens. I'm going to be taking 1/3 times the square root of x squared plus 5, so that's 2 squared plus 5, plus 1/3. And this x, by the way, would be multiplied by this x. If you don't see that, that's x over 1 right there, right? X squared, so that's 2 squared divided by, and down here, this is the square root of 2 squared plus 5. So let's see what happens when we simplify this out. That gives me 1/3 times the square root of 2 squared plus 5. Well, that's the square root of 9. That's 3. Plus 1/3 times, in this case 2 squared, that's 4, divided by the square root of 2 squared plus 5, that is 3. So we have 3/3 plus 4/9. So 1 plus 4/9, if we add those together, that becomes a slope of 4 plus 9, 13/9. And this is our slope of our line. It is the slope of the line tangent to the curve at 2, 2. Now we actually need the equation of the line, and if you recall that the equation of the line could be written in this point slope form, y minus y1 is equal to our slope m times x minus x1. So we're going to make the proper substitutions into the proper places. We're going to get y minus 2 from here, our y value, equals our slope, in this case 13/9, times x minus 2. So putting this together to simplify it, it's going to become something like this: y minus 2 equals 13/9 x minus 26/9. But we're going to be adding 2 to both sides, so add 2, right? A little fraction action here, not going to hurt anybody. Y will equal 13/9x minus, let's see, 2, that's 18/9, right? It's 18/9. To get that common denominator, 18/9. 26 minus 18 is 8, right? So minus 8/9. And so if we wanted to express it in the form of the point slope equation of the line, here's our equation: y equals 13/9 x minus 8/9, and we're done.